Welcome back to our second video in the series for people who have never used MNova or general NMR analysis. As you can see, my NMR spectrum looks different from the one I've been using in my first video. This time the molecule is much more complicated and I've already copied the structure over from ChemDraw. We are not too bothered about the complexity of this molecule, but I thought this molecule gives us a good example on what to look for when we try to analyze an NMR spectrum. In this case, we don't get very much information about the spectrum, only that I obviously have run this many years ago. I still know the compound, but do I see anything? Which NMR solvent have I been using? Most of the time when you run an NMR spectrum, you will use chloroform. However, sometimes your compound isn't soluble in chloroform. What to do then? One alternative is to use deuterated water or deuterated methanol. Deuterated methanol is quite expensive, but sometimes a very good solvent. In this case, I know what the compound has been measured in. I know it has been measured in deuterated methanol. However, the reaction has been carried out in water. And thus, in this NMR spectrum, see not only the compound, but also the residual water, which we couldn't get rid of, and we will also find the signal for methanol. So I would like to briefly show you how to go and analyze this NMR spectrum, and we will repeat quite a number of procedures we have learned in the first video. So first of all, I like to zoom my spectrum in. So hit the letter Z and just check, go from A to 0. That should give me an overview. And I see some clear signals. They are definitely not from a solvent, because I know that in this range I should find the aromatic signals. And I see also here two nice peaks, triplets, that are possibly coming from the chain. I know that this one is an electron withdrawing substituent, so I would expect the signal to be somewhere between 3.5 and 4.5, so that's possibly this one. And since this is a nice shape, I can guess that this signal here is in vicinity, so this means I can find those two CH2 groups quite easily. When I use methanol or water, then I won't see the protons that are sitting on nitrogens and hydroxy groups, at least not in most cases. Why not? Because we have an equilibrium between the solvent and the hydrogen atoms that are sitting on this molecule. We say we exchange those protons. They are slightly acidic, and thus they will exchange for the deuterium you find in the NMR solvent. Thus they will just vanish. Then we have two more protons here in this range, and then we have one special one that sits on the alkyne group. That one is quite easy to spot, because that should be on the lowest shift at the highest field over here. And now we can only guess that this one here are possibly those two CH2 groups. So this leaves us with this long peak and this peak. I can tell you this peak is actually the water peak. It's very characteristic. It's around 4.7. And this one here comes from our NMR solvent, from the deuterated methanol. So if I zoom this one in, you see it has a very characteristic shape. It has this pentate pattern. So we know that must be our solvent. So how did we do this one? We press the letter L to come into the routine for setting the reference, and then we pick the correct solvent, look for our methanol. So we see this pentate here, say OK, and then we have the correctly labeled NMR. So the next thing I want to do is I would like to integrate. So I take a smaller range of my spectrum. I will integrate the aromatic signals over here. I'm not integrating my water signal. Here is a signal. I'm not integrating my methanol signal, but all the remainders I will integrate. So overall this looks quite neat. 1, 1, 1, 1, 2, a half. So there's something dodgy here. So this means in our case we have to multiply the whole spectrum to get a sensible integration. So how do I do this? I right click on one of those integrals and normalize this one to 2, and this will now change all my integrals. Again, I can set this one to 1 decimal, and I can make also the text a little bit bigger. Color is fine. So let's say we go to 11, say OK. So now it's easier to read for you as well. The next thing is the peak picking. Letter K was that. I set a threshold. This case it might be interesting to have a look where the water is sitting and where the methanol is. So I go along the spectrum. Again, I find this one a bit small. I go back to properties, look for peaks, set the font, put this one onto 11, say OK, and I want to have 2 decimals. That's already done, so I say OK, and now I should be fairly happy with this one. In this tutorial I would like to show you also what to do with the carbon-13 spectrum. For this purpose I have a carbon-13 spectrum here already from the same compound, and now everything looks completely different. First of all, we have a completely different scale. If I go back to the other one, here we had a scale somewhere between 0 and 10 or 15, and now we are going to the hundreds. So my spectrum goes at the moment from -20 to up to +220. I see also peaks of different length, and I see here a bunch of peaks. So I can tell you the bunch of peaks are actually from our deuterated methanol. We don't see the water here. Why don't we see the water? Obviously there are no carbon atoms in water, so we won't see water. So whenever you use water as NMR solvent, deuterium oxide, you need another reference compound, otherwise you have nothing to set the reference for. So I start in the same way as for the other spectrum. I want to zoom first. I zoom my spectrum and then make sure that I see the middle peak, my compound, and then I hit the letter L, which allows me to set the reference. I look for the solvent, and it should be deuterated methanol somewhere on my list, and say OK, and my spectrum is now calibrated to the correct reference. Then I want to see the complete spectrum again. And what can I do next? I can't integrate. Integration doesn't really work on carbon spectra, neither on the depth Q nor on the ordinary carbon spectrum. The only thing we can do is peak picking. So I use my middle mouse wheel to zoom in or make our peaks a bit longer, hit the letter K, and then I go along the threshold. I've done this already for my solvent here, and I'm ready to go, and I have basically all the data I want to have.